Hello everyone and welcome to the Sario Dev Show, Engineering IRL, where I go through ways to improve yourself as a young engineer and also how to apply engineering mindset to real life. In today's podcast, we'll probably go through a new topic, obviously a new topic, and today's topic will be, do I need to know how to program as a non-software engineer? Obviously, we're not talking here about requirements. If your job has a requirement, it does not have the requirement. Obviously, it's not a requirement to get a job there. But what I'm trying to establish here is thinking about what advantages you would gain from learning how to program. Now, this doesn't mean the ability to write entire software, a complete application. These are things that include scripting and learning how to troubleshoot, because you can read software. You can read code. So I will focus on from a generic point of view. But firstly, what I'll open with is, you as a young engineer, typically there will be an office component. And even if it's not, this will still probably apply. But there's typically an office component. And what that means is, even with you might be doing requirement specifications, documentation, there's processes. Because as an engineer, you work in a business, there are processes that exist around your work, your workflows. Now, programming from that standpoint could become advantageous, because all the repetitive stuff that you don't like to do as an engineer, you can automate some of those things. And more importantly, if there's processes that exist, you can optimize them. Now, why should I optimize these processes? That's not my job. Well, it's one of those things about, we talk about how you accelerate yourself as an engineer in your career. What happens is, because you have this skill set, you've improved a process that everyone depends on and uses, or it might even be a non-important process. It could be any odd process that you help to improve. Anytime anyone in the business, from low to high to senior, that needs to do that process and you have the best way, they're going to come to you. All of a sudden, you can become an expert in a tiny niche. A little tiny niche, not of much importance, but what you're doing is you're building a reputation over time. Your reputation doesn't come in one day. Anyone that comes in guns blazing, think they already have this number one reputation, I'm the smartest. Everyone that has been there for a long time can see right through it. The only people you're impressing are people that don't know themselves, and they're not the people you want to impress anyways. So you build a niche that you're the expert on. You help improve productivity. You learn the mindsets from other departments and different types of people that want problems solved in other ways. So you're already got a win. Now, secondly, when I think about this question, what I think about is what it enables you to do from a troubleshooting standpoint. So if you listen to a few episodes ago, I taught you the 10 steps to problem solving, to troubleshooting problems. Quick interjection. We had a feedback from one of our engineer colleagues that pointed out that another trick to try is recycling solutions. So add that to part of your secret steps, maybe somewhere between step 8 and 9. Go back to that podcast if you don't know what I'm talking about. And you'll see how it makes sense. The recycling of the solutions is borrowing solutions from unrelated projects or related projects, for that matter, or ones you've used in the past and just chucking in there. Anyway, back to what I was saying, which I actually forget right now. But yeah, sorry, it was to do with the troubleshooting. With the troubleshooting, what you gain is the ability to, sometimes when you have problems, and okay, so sometimes the problem may be related to a software or program, and there's logs, and the logs give you clues to what the problem may or may not be, and a lot of them come in the format of software code. Usually what you see is a bunch of gibberish, but sometimes you can start to make out some sort of clue. That's level 1. You read an error and it says time was slow or whatever it is, time delayed or whatever, rejected because of connection refused. But sometimes when you get more experienced with this, what you start to do is you can kind of imagine the structure of the program and the intention of the programmer behind the function. What were they trying to achieve in the first place? When you look at that, the one thing that can sometimes get you with a program is the function says it adds 2 numbers. So you're trying to troubleshoot why 2 plus 2, when I put in this function, comes out as 5. And you can check all your inputs, you can check the outputs, you can check everything, but there are times when it was just not handled in that situation. The code was wrong. And that can throw you for a long time. And typically you raise it and the issue goes up higher and someone else has a look at it, but you can come to some of these conclusions a lot faster. Okay, so that's that's the second main thing. Helps you troubleshoot, helps you think. Another thing, this may be the last main one, but what you can do is, the way that programming is designed, it's purely designed around solving a problem in the first place. So what happens is you automatically start thinking more critically. You start thinking ahead of time, what are the possible problems, and you design it in. So you as an engineer, you're a designer, you can, when you think from a programmatic standpoint how the entire system can work, and how different pieces fit into the bigger picture, it allows you to have better to make better decisions from a design standpoint. This is very true. This actually is the programming is designed to be solving problems. Why else does the program exist? They're solving problems constantly, and the high level constructs of it are actually applicable to everyday life and to all sorts of engineering applications. Even in the way, if you look at a way that you might manage a team, okay, or the way you work with people working with each other are components of a bigger system trying to achieve a goal to solve a problem. True? Maybe. But I would recommend trying that yourself. Have a look, see if you can apply that kind of thinking to one of the tasks you're working on right now. Could be a uni project, could be something like that, and you're working with a bunch of people and you're trying to figure out how to make it work. Your project team, the project itself is the system. Okay, think of it that way. That's the system. The goal is how to get grade X, and you break it down backwards from there. You reverse engineer it from there. And you do it in system blocks. You do little blocks. So if part of the grade 50% requires this, you break that down to other parts. And then you'll see how everything actually relates to each other. And you can start to see where, from a programmatic standpoint, where you actually need to look at first, where you need to look second. Okay? It's a bit of a hard concept to grasp, but if you have any questions about it, let me know. We can expand a little bit more on that topic. But for now, there's one last thing that I'll add is, and it relates back to the first point, you are working in an office. Aside from the process improvement, the other thing is you're probably going to be working with a lot of office applications. And as an engineer, you'll be working with a lot of data. And here's one really great place where having a programming mindset can really set you apart, is being able to get in a bunch of data that even the other engineers have collected or done, and being able to turn that into meaningful information, or putting into such a system that when it's necessary can be recalled easily. And the first place I say to go is to look at, and this is gonna sound like blasphemy to all the software engineers out there, but chill. There's a very important part of what I'm saying is to look at learning something like Access, MS Access for your database. So learn databases, okay, and learn VBA. Oh no, VBA is not a real programming language. forget all that stuff. Okay. What's important to understand is that VBA is programming for an application. The application's already done. Now, from that application, you have problems you're trying to solve. VBA ties that all in together. You're not designing a program from scratch, which I was saying not to do as a non-software engineer. These are very powerful tools to learn. So many times in so many companies that I've seen, the amount of lists and spreadsheets and text pads and notepads used to store data is ridiculous. Trust me. And they're storing data, and then when it comes to the management of data, it becomes a big shit show, for lack of a better word. Because coincidentally, what is a database? They call it, there's an acronym, DBMS. It means Database Management System. And even forgetting the management system part of the acronym, DB, database, it's a base of data. Okay, a base of data. It's designed for the job of storing data, and it's designed for the management of the data. So use the right tools, you upgrade things to databases and think that way. It also means that when any other application you work with in the future, oh, we've got this database with blah blah blah, with whatever data is your company is working with, you can run queries and you can find the answers and extract them exactly as you need. And again, now you've got a niche as an expert to do this common task that every engineer has to face or deal with. But you can leapfrog all the higher engineers because you can add value to them. They need to do the actual task with the information you pull out, but you can go in and collate the data and do enough smart queries to help solve the problem. The amount of times that I've just ended up running a bunch of scripts against data to formulate new applications and programs and things like that is ridiculous, and the number of times that has resulted in myself getting the nod for a particular job is quite a high percentage. I don't even have a number for you. I'm not even going to bullshit it. But it's a separate skill set that is applicable. Now, databases is not necessarily programming, but there is a lot of programming mindset with it, because once you do the programming, you can not only do the database like queries to get information, you can then present it, you can pull that into another system, you can put that somewhere else that's useful for everyone else, you can generate reports, which doesn't sound super sexy for engineers, but it happens. And if you make really good looking reports, actually it's like a secret joy, because you do end up dealing with them, and good looking ones versus really bad looking ones makes a big difference. I've talked about UI and UX before, but I'll expand into that topic later, but this feeds directly into that. If you start to understand this and decide, you know what, I'm going to pick up some sort of programming, I'm going to try even be a VBA person and do a bit of that, figure out how to get some data, make certain queries and present it nicely, then you're going to, when you want to level that up, you're going to want to look for my podcast relating to that, to UI and UX. Look out for it in the future. That'll be coming an upcoming episode. But for now, you should start. Absolutely, you should start. I'm not going to teach you the exact small details. I can, if you ask so nicely, but resources on it are so extensive. My recommendation is always, you do a basic tutorial, you think of a real life problem with a simple data set, maybe even do it for a personal reason, or something that looks like what your work could look for, big pieces of data, and then learn how to make some basic, so make the data, then think about you can run a tutorial that teaches you how to run a query on that data. So do it for yourself. Like you can get all the data from your expenses, for example, put that on the database, have expense, date, time, and then like you could put in a category, a type, put that in a big field, then find out for yourself, is there a correlation between the date, like public holidays, and how I spend, or even funner, like the time of day, or the day. Does the day impact how I spend? And actually put numbers behind it. Many engineers over time will make big theories, and it comes of feeling and experience, but they will be so appreciative if you've in the background got some data to back up their exact claim. Whew. In the future, anytime they want to prove a point, they come to you, hey, is there numbers to back up what I'm saying? You're the quantifier, you're the go-to. And if you notice, the theme of today is giving you multiple ways to be the go-to, to be the niche guy that solves certain things that people go to for these problems. Now, later on, the negative side, people say, like, oh, but you don't want people coming to you for all sorts of rubbish. Especially early on, your job isn't to learn to say no. Your job is to have it's a good problem when you have multiple things to balance and you're the go-to for several people. That is a good problem to have. Busy is better. Busy is better. It's better to be needed by your own company and relied upon, because over time you can start to become part of bigger decisions, opinions that people want, and then you have the skills and ability to actually add value to a project. And we haven't even talked about the engineering side yet, or your specific engineering. This is in addition to any engineering. If you're going to be a database engineer or something like that, then that's you're already doing this. But what you can gain from this is to think. You're a software guy or you're a database guy. Do both. Like a database guy needs to think more like a software person. Add that to your repertoire. A software person needs to add databases. But you don't need to become an expert in those fields. Get a base understanding. Get some base skills. Be able to run the query that I just said, for example, and then be able to do that as a scheduled report weekly for yourself. Can you achieve that? Let me know if you do achieve it. I think it's a fun little project that you can do. And if it's for your personal money, then put some fake numbers or put some fun fake numbers, but or use some real numbers. That part's not important, but hopefully what you get out, even if you're not even studying engineering, I think it's important to learn some of these principles if you're looking to do a professional job. Even if not, the last thing I'll leave you with is you're hearing articles every single day about the job market changing daily, about digital, about AI, about all that sort of stuff. Everything is going digital. The way the entire world works is going digital. Everything will be completely different. Being able to understand programs and data and things like this will give you an advantage and relevance in the future world. When I say the future world, I'm talking 10 years, 15, 5 years even. It's not that far away. And the better you are at it, the better in the future you're not left behind. Imagine this. You're your parents now, okay, if they're over 40, 50, 60 plus, probably don't know how to use the internet. How, for people so smart, can be smart, how quickly they can look so stupid when they can't understand how to download the internets. All right? Think about that. Think that's how ridiculous you're going to look to the next generation, not understanding how digital works, how things work in a digital world, more so for you guys in the technical industry. All right, so I'm going to leave you with that. This is serious. This is big. So motivate yourself, learn some basic skills, and honestly, they barely go away. You keep revisiting it. You might not be able to build an app. Like when I go back to building apps, it takes a long time to get back into that flow where I'm really, really efficient. But the concepts and the mindset stays forever, stays. You won't lose it. So what I want you to do is go on, figure out what you want to learn something, read something on this topic from programming and a database standpoint. Okay, you can apply it to your own real life, or you can solve an imaginary problem. And then as this is an ongoing thing, you'll find that you'll never be left behind. All right, so with that being said, hopefully you gained something valuable out of this one. I'm not sure how this one's going to come out, but either way, I hope it's good enough for everyone here. I've been enjoying doing these podcasts, and I've been loving all the feedback that everyone's been giving me, so thanks a lot for that. honestly, just reach out. Sorrydev.com, you can find me, and that's it. On to the next one.